So today we are going to bring back something we learned in Unit Module 1, which was distance and midpoint formula. So please make sure you're working on your IXLs. They're due tomorrow, K2, K4, and K5. Let me know if you have any questions. So whenever I see the word length, I'm thinking in my mind hypotenuse Pythagorean theorem or the distance formula. And in this problem, I went ahead and used the Pythagorean theorem because I could easily graph these 2 points. So I graphed and drew my line, PM, and then I made my right triangle here, and I noticed the 2 legs of my right triangle were 5 by 5. Remember, I can't count the length of this line because it's a diagonal. It doesn't hit the line, it doesn't follow the coordinate grid exactly. So 5 squared plus 5 squared is 50. Took the square root and I got 7.1. So that means this black line right here has a length of 7.1 units. Now I want to know what quadrant of the coordinate plane would the midpoint lie. Well, I went ahead and used my formula, which is x plus x divided by 2, y plus y divided by 2, and I found that my midpoint is here, and it's just barely in that first quadrant. Okay, let's review this vocabulary that we're going to need to be successful with this unit. So first of all, a coordinate proof is a proof that places geometric figures in the coordinate plane and uses techniques like distance formula, midpoint formula, and slope formula to complete the proof. And so quickly review the distance formulas here. I'm going to encourage you to try to use the distance formula rather than graphing, just because it's not very often that graph paper will be supplied to you when you're taking the EOC. Okay, midpoint formula again is here, and remember we use the midpoint to find the halfway point between 2 points. We call that the bisector. So that's a key word. And then slope formula is here, y2 minus y1 over x2 minus x1. And again, that tells you the steepness of the line. Is your line a positive line or is your line a negative line? And if so, how steep is that line? Please remember that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. Okay, so you can reference this at any point during today's lesson. So the first thing we want to do is kind of similar to what we did here that I skipped. So this right here is a challenge question, and we're asking ourselves which of the following triangles is an isosceles triangle. And again, you're going to start by graphing the following triangles. So I did that. Here is HOT, triangle hot, and here's triangle SUN, triangle sun. And then secondly, you're going to look at the distance between the lines. So I went ahead and kind of visually said, I'm thinking that this line is most likely going to be equal to this line here, due to the fact that this line was so much longer than the two. And I found this one was 5 by 4 and this was 6 by 2. So I went ahead and plugged them into the formula of Pythagorean theorem, and I noticed I got 41 is not equal to 40. So though they are very close to being isosceles, this one is not an isosceles triangle. So then I went ahead and did the same thing for sun, and I noticed that this was the length of this side right here was 3 squared plus 7 squared, and then the length of this side right here was also 3 squared plus 7 squared, knowing that's going to come out equivalent. It'll be the square root of 58 is here and the square root of 58 here. So I knew that this, in fact, was the one that was going to be my isosceles triangle. So in order to prove that, once again, I had to know my distance formula, and I had to know kind of how to find slope, right? So I knew how to plug those numbers into the distance formula. So that's what we're going to be doing. So we want to prove that this triangle sun is in fact an isosceles triangle. And so the first thing is that your first statement is going to be these coordinate points, right? So you could graph them on the coordinate plane. But like I said, I want you to try to get away from that and actually use the distance formula at this point. So if I want to find the distance of SU, I'm going to take my x coordinates, which I've underlined in red, and subtract them. But remember, minusing a negative 5 makes it a plus. Square it. Then I'm going to take my y coordinates, which I have not outlined. I have 3 minus negative 4, which is 3 plus 4. Square that. I ended up with 9 plus 49, which is the square root of 58. And you can see that that's where the 7 and the 3 came from. 7 squared is 49, 3 squared is 9. You add that together, you get 58. And then you're going to do the same thing for u to n, okay? And in this case, I got right here, negative 5 minus 2 is 7 again. And then negative 4 plus 1 is 3 again. So that's going to leave me with 9 plus 49, which is the square root of 58. Now, because I know those two are congruent, I'm not even going to go back and do Sn. I could, let's say I want to do that in purple. It's going to be the square root of, so let's get my x coordinates, of s, which is going to be here, and n, which is going to be here, okay? So it'll be negative 2 minus 2. And right away, I already know that they're not going to be congruent. Minus 2, and then squared, plus my y coordinates, which are 3, minus negative 1, which is plus 1. So, and that's going to be squared. And that's not going to equal 49 plus 9. That actually equals, let's see, that's negative 2 minus 2, that's negative 4 squared. Well, that's 16. And this is also 16, so it's going to be 16 plus 16, which is not 58. 16 plus 16 is 232. So that's the square root of 32 here. All right, so that's not going to be equivalent to these two, but knowing that these two are the same, I can say that this is going to be an isosceles triangle. Okay, so the distance of SU was the square root of 58. And we're going to use these numbers here to prove, and the distance of UN was also 58. So using the distance formula, I can prove that those two are congruent. So I can say here that SU is congruent to UN, and the reasoning is equal measures is equal segments. Because these are both the square root of 58, we can say they have equal measures, therefore they're going to be congruent segments. So triangle SUN is isosceles because isosceles triangles are triangles with two congruent sides. So I've now proven, using a two-column proof, that SUN is in fact an isosceles triangle. This is one example of a proof that you can do on a coordinate plane. Okay, another example of a proof that you can do in a coordinate plane is to prove that these two triangles are, let's say, perpendicular bisectors of each other. So if they're perpendicular, you know they're going to have opposite reciprocal slopes. And if they're bisectors, they're going to have to cut each other in the middle. So the first thing I would do if I'm going to solve this is I would go ahead and graph CD, and then I would go ahead and graph AB. So 0, 5. See, 1, 2, 3, 4, 5 would be here. And D is at 4, negative 3, so that's 2, 4, 1, 2, 3. Wow, this just fits. So I'm going to draw my line here. Okay, and then my second mark here is at AB, and that's at 0, 0, so that's the midpoint. I'm sorry, I don't know why I said midpoint. I meant origin. And then 4, 2, which is here. And I want to prove that these are perpendicular bisectors of each other. So the first thing I'm going to do is gather my Lord, what happened there? Gather my important information, okay? So my important information is the slope of CD, which I know it's negative because the line's going down. So I'm just going to go ahead and put my negative sign. And I'm going to count. Let's see, it's 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 over 1, 2, 3, 4. Negative 8 over 4, which simplifies really to negative 2. All right, and then I'm going to find my slope of AB. And again, I'm finding the slope in this case to prove that they're perpendicular. Okay, so this is the part where I'm proving perpendicular. So let's see, I go up 1 over 2, up 1 over 2, so my slope is positive 1/2. Yes, they do bisect. So I've proven that negative 2 is the opposite reciprocal of 1/2. So now I got to find the midpoint. Please remember, midpoint formula is x plus x divided by 2, y plus y divided by 2. And I know that because I went back to this page right here and I looked up, there's my midpoint formula. Okay, so my x coordinates are 0 and 4. 0 plus 4, that's going to be divided by 2. And then my y coordinates are 5 minus 3. So that's what, 3 divided by 2. So this becomes 4 divided by 2, which is 2. And 5 minus 2 is 3. I don't know why I put a 3 here. This should be a 2. My bad. 3 over 2, which is 1.5. So let's see if that hits that line right there. At 2. Ooh, it's close. So let's look at the red line and see where that hits, because it might be a mistake that I made. So AB, let's see. 0 plus 4 divided by 2. So yes, that lines up at 2. And then the other point is at 0. Oh, I see the mistake I made. Sorry, babe. This is supposed to be a 1, not 1.5. I made a small error here. So this is why it's important to check your work, because this is 0 plus 2 divided by 2. Hopefully you can go back and see where I made my error in the first example. So this is 2 divided by 2, which is 1. Up here, if you notice, I put 5 minus 2, but it's supposed to be 5 plus negative 3. So I'm going to go ahead and correct that now. This should be a 3. So 5 minus 3 is 2. 2 divided by 2 is 1. And so since I get the same point for both, yes, I can prove that these are going to have the same midpoint. All right, so that's given. The slope of CD we said was negative 2. The slope of AB is 1/2. And my reasoning for this, again, is slopes of two lines, opposite reciprocal lines are perpendicular. Then I got my midpoint of CD, whew, after all those mistakes, is 2, 1. But mistakes are okay as long as you check your work and find them. You can really learn a lot from a mistake. And then the midpoint of AB is also at 2, 1. And that was the midpoint formula. So I can say that they bisect each other because segments have a common midpoint. The segments are going to bisect each other. So now I can in fact prove that these two are perpendicular bisectors of each other because the segments are cut into two congruent parts at a 90-degree angle. All right, so this is my statements and my reasons. And again, the hardest part is to do the math to prove that this is in fact the case. All right, I do have a second video so we can do the other two example problems. And I would like you to log out of this one and go ahead and go back to Canvas and watch the second video.